For transcription, we're going to use another enzyme, ASE. We're going to use RNA polymerase. Now, RNA polymerase is going to do the job of helicase and DNA polymerase all rolled into one. Essentially, it's going to split open our DNA strand, but it's also going to build our mRNA strand. So RNA polymerase is pretty efficient. So again, we're going to start with our anti-parallel strands. It's going to go through DNA polymerase and it's going to split. Okay, when we get here, this is where we have our active site. So we're going to read what the DNA strand says, which this is T. This is where we put our first complementary base pair for RNA. So here we have adenine, because T pairs with A. Our second one is A. A, instead of having thymine, remember we're transcribing, so we're making a copy, but it isn't perfect. Instead of thymine, we're going to have a new player called uracil. So uracil is now going to go in here. And this is going to keep reading. So our next one that we're reading is a cytosine, which means we're going to see guanine as our complementary base pair. Guanine is the complement. And we're going to keep building this. The next one that we have is another guanine, actually. Just want to notate that RNA polymerase also rewinds our DNA strand. As it's going through, it's also going to close our DNA strand back together. So nothing's wrong with it as we're synthesizing or making our mRNA strand. Okay, so what we ended up with is, remember our original DNA strand that we made? We ended up with our transcription, our copy of DNA, but now it is RNA, specifically mRNA, and the M stands for messenger. So now we can actually take this blueprint and leave the nucleus. Whenever we leave the nucleus, go straight to the ribosome, which also is rRNA, ribosomal RNA. It has this small ribosome subunit and this large ribosomal unit at the top. It's going to enter the ribosome, and the ribosome is going to read. Now remember, we said the first 3 of DNA is a triplet. Because this is mRNA, this is a codon, which means tRNA is going to read this and bring our anticodon. We have AUG, which is our codon. Our anticodon is going to be is our tRNA. So our tRNA reads the codon, brings the anticodon as well as an amino acid. So A pairs with U pairs with A, C to G. So now we've read this, and we're going to keep on moving, and this is where our protein chain is going to exit. Okay, so the next one is going to be, we have CCA, GGU is our anticodon. This matches, and we're bringing another amino acid. So as we keep reading, this is where our amino acids are going to converge, because remember, the amino acids are the building blocks of protein. So then we have our next set, which is UGG. So our anticodon is going to be ACC, and ACC is going to be tryptophan. So here, there's another tRNA, and as it's going through, we're building this polypeptide chain, aka we're building our protein. So here we can see the protein is exiting. This one's missing a sticker, but this is glutamic acid. As this goes on, here we go. Our tRNA also doesn't just stay here. It, detaches. So it's going to detach and go on and do its thing. We're reading the next one. We have 3 stop codons. The one that we're going to use is UGA, and a lot of professors will tell you U go away is a good way to remember that. There's 2 others, so we're going to use UGA as our stop codon. And this just lets our ribosomal unit know that it's time to stop synthesizing a protein. So here is our protein chain that